So, hello, this is Aditya Bhardwaj, and today I'm going to talk about the topic attention mechanism, which is a concept of natural language processing. So, I will start by presenting my screen. Okay, so I will start by introducing the topic. Attention mechanism is one of the recent advancements in deep learning, especially for natural language processing tasks like machine learning, image captioning, dialogue generation, etc. It is a mechanism that is developed to increase the performance of encoder-decoder RNN model. In this presentation, I will try to explain the attention mechanism for the text classification tasks. So now coming to the motivation in NLP tasks, understanding the relationships and dependencies between different words or tokens is a sequence in the sequence is crucial. However, traditional sequence processing methods like recurrent neural networks and long short-term memory LSTM networks can struggle to capture long-range dependencies effectively. Attention mechanism addresses this limitation by enabling the model to focus on relevant parts of the input sequence at different positions. So the basic idea is like imagine you are translating a sentence from one language to another. When translating a specific word, we might want to pay more attention to certain words in the source sentence that contribute to the translation of that word. Similarly, in a text generation task, we might want to focus on different parts of the input context when generating each word. Attention mechanism simulate this selective focus by assigning different weights to different parts of the input sequence. So attention is proposed as a solution to the limitation of encoder-decoder model, which encodes the input sequence to one fixed language vector from which to decode the output at each time step. This issue is believed to a problem when decoding long sequences because it makes difficult for the neural network to cope with long sentences, especially those that are longer than the sentences in the training corpus. In attention, when the model is trying to predict the next word, it searches for a set of positions in a source sentence where the most relevant information is concentrated. The model then predicts next word based on context vectors associated with these sources, positions, and all the previous generated target words. How attention works. The basic idea in attention is that each time the model tries to predict an output word, it only uses parts of an input where the most relevant information is concentrated instead of an entire sentence. That is, it tries to give more importance to the few input words. In attention, the encoder works as similar to encoder-decoder model, but the decoder will behaves differently. As we can see from the picture, if I if I talk about this picture, uh, the decoder's hidden state is computed with a context vector, the previous output and the previous hidden state, and also it has separate context vectors ci for each target word. The context vectors are computed as a weighted sum of activation states in forward and backward directions and alphas, and these alphas denote how much attention is given by the input for the generation of output word. So, talking about the key components, first one is query. The query vector represents the current position or word being processed in the output sequence. It captures the context or information needed to generate the next output element. The second key component is the key. The key vector represents different positions or words in the input sequence. They encode information about the input sequence. The third key component is the value. The value vectors correspond to the values associated with each key. They represent the information that the model will focus on. Now coming to attention score calculation. Attention scores are calculated by measuring the similarity or compatibility between the query and each key. One common method is the dot product. The higher the dot product, the more similar the query and keys are. The scale dot product computes the dot product after scaling the keys to have unit norm. This scaling prevents the gradients from becoming too large during training. Learned functions can also be used to calculate attention scores, allowing the model to learn complex relationships. We're talking about softmax weights. The attention scores are transformed into weights using the softmax function. Softmax converts the scores into a probability distribution, ensuring that the weights sum up to 1. Higher attention scores result in higher uh, weights, indicating that the corresponding positions in the input sequence are more important for the current output positions. Talking about weighted sum context vector, the weighted sum of the values using the softmax converted attention scores generates a context vector. The vector captures the aggregated information from the input sequence, emphasizing the most relevant parts based on the attention mechanism. Next one is the integration with model. The context vector, which is formed, is then combined with the output of the current position to generate the final output or prediction for that position. The integration can happen in various ways depending on the specific model architecture. So now talking about multi-head attention, the transformer architecture introduces multi-head attention where multiple sets of queries, keys, and values are computed in parallel. Each head learns different patterns and dependencies, providing richer context representation. Head specialization. Each attention head is a multi-head attention mechanism can specialize in capturing different types of relationships within the input data. For example, some heads might focus on local dependencies, while others attend to global patterns. The specialization allows the model to learn a more uh, nuanced and comprehensive context representation. Ensemble effect. Multi-head attention can be seen as an ensemble of attention mechanism. By combining the outputs of multiple heads, the model benefits from the diverse perspectives captured by each head, resulting in a more robust and accurate context understanding. Splitting. In practice, the input embeddings are often split into multiple subspaces, and each attention head operates on a different subspace. This can help model enhance the relationships such as syntax and semantics. Uh, in the Now talking about self-attention, in the context of transformers, self-attention refers to applying attention mechanism within the same input sequence, allowing each position to focus on other positions. This enables the model to capture both local and global relationships efficiently. Capturing long-range dependencies, self-attention allows a token to capture relationships with all other tokens in the sequence, regardless of their distance. This ability to model long-range dependencies is crucial in understanding context and semantics across different parts of the input text. Positional information. In self-attention, positional encodings are added to the input embeddings to provide the model with information about the positions of tokens. This ensures that the model can differentiate between tokens with the same content but different positions, thus preserving the sequential order. Talking about masked self-attention, in scenarios like language generation, where the model generates one token at a time, it's important to prevent the model from attending to tokens that haven't had self-attention. Achieves this by masking out future tokens during generation. Now, concluding this topic, the attention mechanism has revolutionized the landscape of natural language processing by addressing the challenges of capturing long-range dependencies and contextual relationships within sequences. By allowing models to selectively focus on relevant parts of input data, attention mechanism enable a deeper understanding of context and enhance the quality of prediction and generations. The concept's foundation in cognitive processes such as spotlighting information, hacking to human attention has led to significant advancements in various NLP tasks, including machine translation, text generation, sentiment analysis, and more. Uh, the introduction of multi-head attention and self-attention in architectures like transformers has further amplified the mechanism's impact, facilitating the model of intricate patterns and enabling the development of state-of-the-art models. As attention continues to be a central pillar in NLP research, it promises to further shape the field's future innovations and applications. So this was about the self-attention. Now I'm going to talk about our NLP project, which is event extraction from news event. So the team members are myself, Aditya Bhargava, Sayam Tak, and Pratik Mohanty. So these are the topics we will go through in this PPT. First, I will talk about the introduction, then approaches to event extraction, then the methodology followed, and then I will conclude it. Now, first talking about the introduction, the rapid growth of digital data sources has led to a pressing need to extract meaningful information from unstructured data for informed decision making. However, the inherent challenges lies in the unstructured nature of most data, which is described using human understandable language, limiting its machine interpretability. This poses a hindrance to automating processes such as information retrieval and extraction, particularly when dealing with large volumes of data. Text mining addresses the extraction of information from pre-processed text, often utilizing natural language processing techniques. Through text mining, information is extracted from various sources like news messages and blogs, structured and stored in databases. An important subset of knowledge extracted through TM is events, complex combinations of relations associated with empirical observations from text. Event extraction from unstructured data, like news messages, has various applications. It enhances the personalized news systems, allowing accurate message selection based on user preferences and identified events. Events also find utility in risk analysis, monitoring systems, decision making support tools, and the medical domain. Furthermore, events extracted from text could play a role in algorithmic trading, where computers use algorithms to make informed trade decisions based on breaking news and economic events. Considering the potential application of event extraction, this study aims to investigate suitable text mining techniques for this purpose, focusing on event detection. The paper lacks a comprehensive survey on event extraction from text, which this work seeks to fill. The objective is to provide guidelines for selecting approximate text mining techniques based on specific event extraction tasks and user context, similar to guidelines developed for cross-lingual research systems. The study acknowledges the omission of space and time event dimension from its scope. The evaluation of event extraction approaches is based on several criteria. The review categorizes data availability as medium, high, or low. It assesses the amount of data required for each approach, the necessary domain knowledge, the level of user expertise needed, and the interpretability of results. In essence, the study addresses the critical challenge of event extraction from unstructured text, providing a comprehensive overview of approaches, methodologies, and considerations. By exploring suitable text mining techniques and evaluating their performance across various criteria, we aim to contribute to the advancement of event extraction technologies and their application in decision-making processes. Event extraction from news articles refers to just the process of automatically identifying and extracting information about events such as the type of event, the actors involved, the location, and the time of the event from news articles. The goal of event extraction is to automatically summarize and organize the events mentioned in a large collection of news articles, making it easier to understand and track the events. Three main approaches to event extraction is the next topic. So these are the three main approaches to event extraction. The first one is data-driven event extraction. So talking about this, data-driven approaches are commonly used for natural language processing applications. These approaches rely on quantitative methods to discover relations. Data-driven approaches require large text in order to develop models that approximate linguistic phenomena. Furthermore, data-driven text mining is not restricted to basic statistical reasoning based on probability theory, but encompasses all quantitative approaches to automated learning processing, such as probabilistic modeling, information theory, and linear algebra. The second approach is knowledge-driven event extraction. In contrast to data-driven methods, knowledge-driven text mining is often based on the patterns that expresses rules uh, representing expert knowledge. It is inherently based on linguistic and lexicographic knowledge as well as existing human knowledge regarding the context of the text that is to be processed. This alleviates problem with statistical methods regarding the meaning of text. Information is mined from corpora by using predefined or discoverable linguistic patterns, which can be either lexicosyntactic patterns or lexicosemantic patterns. The former patterns combine lexical representations and syntactical information with regular expressions, whereas the later patterns also make use of semantic information. The third approach is hybrid event extraction. In hybrid event extraction systems, due to usage of data-driven methods, the amount of required data increases, yet typically remains less than in the case with purely data-driven methods. Compared to a knowledge-driven approach, complexity and hence uh, required expertise increases due to the combination of multiple techniques. On the other hand, the amount of expert knowledge that is needed for effective and efficient event discovery is generally less than of a pattern-based methods because of the fact that lack of common knowledge can be compensated by the use of statistical methods. As for the interpretability attributing results to specific part of the event extraction is more difficult due to addition of data-driven methods. Yet interpretability still benefits from the use of semantics. Disadvantages of hybrid approaches are mostly related to multidisciplinary aspects of hybrid systems. Now, next, we talk about the methodology that we are going to follow for this project. The first one is obviously libraries used. We would start by importing the necessary libraries and tools. For event extraction, we might use libraries like NLTK, Passy, Beautiful Soup for web scraping, Pandas for data manipulation, Matpot, Plotly, or Seaborn for visualization, and Scikit-learn or TensorFlow for modeling. The second stage would be web scraping the data. Web scraping involves extracting information from websites. In the context of event extraction, we would scrap news websites to collect articles uh, related to events we are interested in. Beautiful Soup or other similar libraries can help uh, pass the HTML and extract relevant information. The third stage is converting the data to CSV and loading it. After scraping the data, we can store it in a structured format like CSV. Pandas is a powerful library for data manipulation, including reading CSV file, and it allows us to reload the scrapped data into a data frame. The fourth stage is the overview of the dataset. Analyzing the loaded dataset to understand its structure and contents is the thing we do in this stage. Looking at the columns, data types, and initial rows to get an overview of the data we have collected is also included in this part. The fifth stage is pre-processing the text. Text data requires pre-processing before it can be used for event extraction. This involves tasks like lowercasing, removing punctuation, tokenization, which means splitting text into words or phrases, removing stop words, and possibly stemming or lemmatization to reduce words to their base forms. Libraries like NLTK or SPACY can assist with these tasks. The sixth stage is the visualization. Visualization helps us understand the characteristics of the data. We might create word cloud, bar plot of most frequent words, or timelines of event based on publication dates. These steps helps in identifying patterns and trends in the data. The seventh stage is the training and testing. So, dividing our pre-processed data into training and testing sets is the thing we do here. The training sets is usually used to train the event extraction model, while the testing set is used to evaluate its performance. The common split is around 80% for training and 20% for testing. The eighth step is the modeling, choosing a suitable machine learning or natural language processing model for event extraction. This could involve techniques like named entity recognition to identify entities and their relationships, or more advanced methods like dependency parsing to understand the grammatical structure of sentences. The last and the final step is verifying our results. After training the model, evaluating its performance on the testing set. Measure metrics like precision, recall, and full score to assess how well the model is extracting events and their components. You may need to fine-tune the model parameters of experiments with different algorithms to improve results. So these were the 9 steps. So event extraction is a complex task, and success depends on the quality of the data, the pre-processing steps, and the choice of appropriate models. It's an iterative process that involves refining its state based on the insights gained from the previous ones. In conclusion, event extraction from news feeds is sophisticated information uh, processing task that harnesses the power of natural language processing and machine learning to transform unstructured textual data from news articles into structured insights. This process holds significant value in understanding, summarizing, and analyzing large volumes of news content. In essence, event extraction from news feeds brings order to the chaos of unstructured textual data, enabling us to get valuable insights and knowledge from the vast sea of information available in news articles. This process has far-reaching implications across industries, allowing us to stay informed, make data-driven decisions, and uncover hidden connections that shape our world. So this was a brief overview or high-level design or idea which we are going to follow for our project. And yeah, that's it. Thank you.